So today we're going to do Unit 2, Section 2, solving linear systems using substitution with 3 variables. So last time we did 2, now we have a third. So nothing too different, just an extra line, an extra equation, a little more work. So we're going to start off the same way. We're going to solve for one letter first. Doesn't really matter which one you pick, but I'm going to go ahead and go with x. Just because x is by itself, I don't have to divide anything at the end. I'm going to go ahead and do that one. You can do either one you want to. On any equation in any order, you should get the same answer. So I'm going to go ahead and solve for x, which means I have to move the 2y and the 3z over here. So minus 2y becomes plus 2y, plus 3z is minus 3z, which would remove them. Now I have x equals, and I'm just going to write what I have on the right side, 11 plus 2y minus 3z. And I solve for x. Now from here, I'm going to take this, x right here, all of that, and plug it into one of these other x's. That way I can solve for a different letter. So I'm going to choose the top just because y is all by itself and there's no number in front of it, so I'm going to do that. Again, you don't have to go in that order. You can go in whatever order you'd like. I'm just going to go in this order. So I'm going to write 2, and instead of x, now I'm going to replace it with 11 plus 2y minus 3z. And then keep going. So plus y minus 4z equals negative 13. Okay, now I can solve, or distribute and solve for y or z, whichever one you'd like. It doesn't really matter. So I'm going to go ahead and distribute the 2 because we have to, because of parentheses. So 2 times 11, 2 times 2, y, and 2 times negative 3z. And then of course this doesn't change yet because we haven't done anything else. So now we can combine like terms. That would be the next thing we would like to do. It'd be easiest to do, so I have 4 plus 1y. And I always just like to do the letters first. It doesn't really matter. You can do the 22 first if you'd like. Negative 6z minus 4z plus 22, because it's positive, equals negative 13. From here, you can decide to solve for y or z. I'm going to go ahead and go for y, only because I know I'm going to have to divide one of them, and it's easier to divide 10 by 5 versus 5 by 10. I don't want fractions if I can help it. So I'm going to go ahead and solve for y, which means I got to move 22 and 10z. Whoa. Let me erase that. 10z. And now I have 5y. So negative 13 minus 22 is negative 35 plus 10z. And look at that. Now when we divide by 5 on everything, because we have to, it divides nicely into whole numbers, no fractions. So that's great. So we have y equals negative 35 over 5 and 10 over 5z. And there's y. Alright, now before we use our last equation to solve for z, I'm going to go ahead and take this y right here and plug it into this y. That way my x and y's only have z's, so that I can solve for z on the last equation. Now you can do this now or you can do it later, but either way you're going to have to do it. So I go ahead and do it now before I put anything else into any other equation. So I have x equals 11 plus 2. Now instead of y, I'm going to go ahead and write what we just solved for. Negative 7 plus 2z. And then minus 3z. Now I can go ahead and distribute, and this will definitely help me in a minute. So 11 minus 14 plus 4z minus 3z. And I have like terms. So 11 minus 14, that is negative 3. And then 4z minus 3z is just 1z. So now I have this x with a z, I have the y with a z. I can plug both of those into my third equation, which is right here. I haven't used that one yet. And then I can solve for z and get a number. Once we get the numbers going, it'll really start to make sense and we'll kind of close in on the answer. So I'm going to go ahead and plug this in. So we have negative 3 parentheses. Now I'm going to go ahead and write the x we just solved for down here. Negative 3 plus z. Okay, and then we have plus 3, and instead of y, we're going to plug in this y right here that we had, negative 7 plus 2z. And then just finish out the equation, so then plus z equals 8. Okay, now we have to distribute on both parentheses, and then we're almost done. So I'm going to go ahead and distribute these. And then we can combine like terms, solve for z. So negative 3 times negative 3, negative 3 times z, 3 times negative 7, and 3 times 2z. And then of course plus z equals 8, that has not changed. Now we can combine like terms. We have 9 minus 21 is negative 12, and then minus 3z plus 6z plus 1z. That'd be 3 plus 1 is 4. Z equals 8. Okay, now we're trying to get z, so we have to move the 12. Right, now it's just a two-step equation. 8 plus 12 is 20, and then divide by 4 to get z, and z equals 5. Yay. Now that we have z as a number, we can go back and plug the z, the 5, into both the x and the y to find x and y, right? So let's do y. Oh no. Alright. So y equals negative 7 plus 2 times, and then of course z was 5, right? So we distribute or multiply. So y equals negative 7 plus 10. So y is 3. Now do the same thing with x. So x equals negative 3 plus, and then z was 5, right? So x equals 5 minus 3 is 2. Now, we have all three numbers, which is what we want. But, you know, there's always the technical way to write it, the correct way to write it. So we're going to do that. So we have x, y, and z, right? Now, this is a point because these are three equations. So what you want to write is parentheses, x, y, and z, because that would be a point in a three-dimensional plane. That's where they all intersect, and that's what you're finding. So that would be our right way to write this answer. And as long as you have the numbers, you're still good, but, you know, if you want to write it the correct way, it'd be with parentheses. And that's how you do number 1. So kind of a long process, not too bad, not too hard, it just takes a while. Okay, so let's do one more of these, but this one has a special situation, like always. So again, you can solve for any of these in any order, just because I know which ones to solve for the shortest way. I'm going to go ahead and solve for z right here in the middle, which means I have to move the x and the y, so I would do plus 3x plus 3y. So I'm going to go ahead and write that down here. So I'd have z equals 8 plus 3x, oh I'm sorry, it's minus 3y. minus 3y. Okay, I solved for z. Now you can plug that z into the top equation or the bottom. It really doesn't make a difference, but I'm going to go ahead and plug it into the top. And so now this z, which is going to go in for this z right here. So I'm going to go ahead and write this over here. 6x minus 6y minus 2, and then instead of z, we're going to go ahead and write what we found. 8 plus 3x minus 3y. And of course that equals 10. Okay. So we want to go ahead and distribute first and then figure out if we're going to solve for x or y. We don't know yet. So I'm going to distribute the 2 and multiply all these. So 6x minus 6y. Negative 2 times 8 is negative 16. Negative 2 times 3x is minus 6x. And negative 2 times minus 3y is plus 6y. Equals 10. Now we combine like terms. Here's where it gets kind of funny. We have 6x minus 6x. That's 0. Negative 6y plus 6y. That is also 0. So what do we have left? Negative 16 equals 10. And because that equation is false, right? Negative 16 does not equal 10. It's false, which means our answer, our actual answer, is no solution. Now, if the equation were true, it would be all real numbers or infinite solutions. So depending on what you get, it's either true or false, so it's no solution, or infinitely many, or all real numbers, however you want to write that. So yeah, so most of the time you'll get 3 numbers and get an actual point that they cross. Other times, like number 2, it just doesn't work out, or everything works out. Either way.